Good evening, everyone. I am Ramya, and I will be your host for today's session on artificial intelligence and machine learning for software engineers, cutting through the data science hype. Thank you so much for joining us today. This webinar is brought to you by Verwin Technologies. Before we begin, I would like to give you all a brief introduction about Verwin. Verwin is an online career platform for young professionals who can get free career guidance from industry and subject matter experts in various fields. We also offer content on work trends, career tips, and tricks to help you learn and grow professionally. In addition to that, we provide an avenue for exciting job opportunities by partnering with companies who are looking out for bright talent just like you. Please log on to www.woven.com and register to be part of our online community. Now, I would like to introduce to you all the speaker of this session. With great pleasure, I welcome Mr. Ramjee Ganti, founder of dblue Inc., a company that helps in monitoring machine learning models. Mr. Ganti is an alumnus of IIT Kharagpur and has 17 years of experience in building and scaling web and mobile products. He has led product engineering for various startups like Just Eat India, Datalicious, BigDecisions.com, to name a few. Currently, he mentors and advises multiple startups. In this webinar, Mr. Ganti will discuss how to rewire your career as a software engineer without participating in the how to rewire your career as a software engineer and participate in the artificial intelligence world without actually moving into data science. This session will be divided into two parts. First, Mr. Ganti will take us along the topic of the session for 30 minutes. After that, we will have a 15 minutes Q&A session, which will be moderated by Mr. G. Srinivasan. We will try to answer as many questions as possible, so please feel free to use the live chat box during the course of this webinar to type in your queries. Lastly, I request all of you to stay on mute at all times. Now, Mr. Ganti will take over the screen and start with the presentation. Over to you, Mr. Ganti.
Ramya, just mic check. You can hear me?
Yes, I can hear you.
Sure. Yeah. Good afternoon, everyone. Thanks, Ramya, for the introduction. This is about me. Ramya has already mentioned that I was heading technology at Just Eat. When I took over the technology as a head of technology over there, we were doing about 100 orders a day, and we scaled to close to 100,000 orders over a span of few years. Just Eat was acquired by Foodpanda. Um, and subsequently, I was working with a company called Big Decisions, where we are helping people like you and me with their personal finance choices, whether you should be buying a house, whether you should not be buying a house, whether you should, how much insurance should you have, how much life insurance, how much health insurance, what should you save so that you have a secure future and things like that. Um, this was a company which was acquired by News Corp. Subsequently, I was with a company called Datalicious, which was into marketing analytics. What we were doing there was helping various companies with their decisions around how much money they should be spending on various campaigns. So should I spend more money on Facebook ads versus Google ads, or maybe I should spend on Twitter? Where can I get the maximum benefit or the returns for the money that I'm spending, right? Now, if you see the common thread across all of these, it has been that in all these companies, we were handling large amounts of data, and subsequently we were making a lot of data-driven decisions, right? Yeah. And today's talk, I primarily would talk about how software engineers who aspire to take part in machine learning, they should think about uh, their own careers in software engineering and what are the necessary concepts. I don't call them skills because skills can be learned and unlearned. Concepts are something which you have for life, right? So what are the key concepts that you need to learn, and the key changes that you might want to kind of make in your approach to building or writing software, right? um, I'm just stopping the video just in case you have a problem with the voice. Yeah. Now on the data science, we all keep hearing data scientists, machine learning, and especially this has become um, almost on a daily, hourly basis. If you are in the area of software, you keep hearing about this thing. Now, does it really deserve this kind of hype? What exactly are we talking about when we say data science? And why is it that everyone is clamoring around, oh, I want to do this data science course? If you go and search on Google, you would probably find a few 100,000 courses on data science itself, right? Now, when you have so many courses, isn't it a paradox that you still have a dearth of both data scientists and people who understand this, right? So there is something not very right, which is also something, and that's because, I mean, fundamentally it has to do with how these courses teach you and also the whole field itself, right? Which we'll touch upon as we go forward. Now, how is this whole data science different from software engineering? Like most of us are in software, we also should kind of see how is it different from the current software engineering thing, and what are your options if you don't want to be in the data science but you want to still be in this space, right? So before we move on with all of these questions, let's first understand what is data science, right? It's a whole lot fuzzy, right? I mean, there is no standard or a specific definition of data science because data science is not one field. Data science is a multidisciplinary field which has a various different disciplines, right? And that is also the reason why most of these courses, or rather I should say, in spite of having so many courses, there is there is no holy grail of, or there is no one single course which covers everything, because it's not possible. You have lots of courses which attempt to teach you data science, but they can only cover a few of these. They cannot cover everything. Let's kind of at least name them. I mean, some of the few areas that we have, right? So for first and foremost, we have statistics. It's pretty essential. Then you have other areas like pattern recognition, neural computing, and AI. We'll see in a different slide what all AI contains, but AI, machine learning, you have data mining, you have database, the processing, you have visualizations, right? All of these combined, and each individual, uh, each one of them by themselves is a huge ocean in itself, and data science is a combination of many of these things, right? Now, it should be obvious to you that people who claim to be data scientists are not necessarily good in all of these areas. They probably are good in some of these areas, right? So it's essential that we all sink in that data science is truly multidisciplinary, and add to this the business knowledge itself, right? The domain specific knowledge that you bring in, whether you are from e-commerce, whether you are from publishing, whether you are from um, the industry, right? Wherever it is, that knowledge also adds up here, right? And that's the reason why you see that in spite of having so many courses, it's hard for people to uh, kind of have one course which fits everything, right? And now let's kind of look at what we keep hearing a lot more about, right? We one hear about data scientists, and then you hear this term in industry, AIML, AIML, AIML. Everywhere it is AIML, right? So why is this that AI and ML always go together? Are they different? Are they not? And if you look at this diagram, you see that ML is a subset of AI. AI is a lot more things. This diagram does not necessarily depict all the areas that encompass artificial intelligence. But if you look at it, the key things are machine learning, you have NLP, which is the natural language programming, and deep learning. Deep learning is itself a subset of machine learning, right? And AI also contains many other things like expert systems and all, but those and all are not so popular in these days. Now, why is AI/ML so popular? Because ML has been one of the primary techniques to do AI in the last decade or so, right? And that is the reason why there is such a strong association between AI and ML, though there are many other AI disciplines and technologies. Machine learning in today's world kinds of garners the biggest mindshare. Now, within machine learning, another technique called deep learning is kind of picking up in the last 5 years, 5 to 6 years. To be precise, deep learning's hockey stick growth started about 2012, right? With a deep learning algorithm called AlexNet. Now, since then, deep learning has been growing by huge strides and bounds. The primary difference between a traditional machine learning and deep learning, which is again a subset of machine learning, is, think about it this way. If you are training a robot, you give the robot all the instructions on what it should be doing, and the robot understands those or interprets those instructions and behaves accordingly. That's kind of machine learning, right? With deep learning, you just tell robot, this is the target, I want you to do XYZ, and this is the data, you go figure out, right? And it will figure out how to translate whatever data it received to the target that it has to do. Like, let's say we talk about in today's world, we keep hearing about deep fake videos where two videos of different persons, they are overlapped and merged together. Then you hear about fake images, right, which the computer generates. So all of this is possible because you are not specifying, I want to do this. What you are specifying is, this is the image, this is the end result, you go figure out what to do, right? That's in a nutshell what deep learning is. Now, let's look at another aspect of why this whole data science thing has taken off in the last decade or so, right? If you look at it from 2010 to 2020, there is a 25x growth in the data that is going to be generated. So in 2010, it was 2 zettabytes. And today, in 20, the forecast is we will generate 50 zettabytes of data. And the projection is that in 2025, it would be 175 zettabytes. As you can see on the slide, 1 zettabyte is equal to 1 billion terabytes. Take a moment to sink that in, right? We're talking about 50 billion terabytes of data, which is going to be generated in 2020, and this is only going to increase. Now, you need somebody to go through this data, make sense of it, and use this data in a useful manner for the business applications, right? Who is going to do that? And that is where data scientist comes in. Data scientists are the people who will do this for you. Let's see how Josh Wills, he is the director of data science at Slack. Slack is a messenger platform which at least some of you are familiar with. So Josh Wills, he puts it as a person who is better at statistics than any software engineer, and a software engineer who is and better at software engineering than any statistician, right? So you have a data scientist, which again, as we see here, is a culmination of two different skills. Like, one is software engineering. They are better in statistics than any software engineer, right? And they are better in software engineering than any statistician. This combination is what makes data scientists, right? One more thing which I would add to this, to what Josh mentions, is data scientists are also very well aware of the business context. They know the domain very well, right? Now, where does that leave you as a software engineer if you don't want to participate in the data science thing? If you say like, okay, I want, for whatever reason, right? I mean, I don't have the attitude or I don't have the aptitude, or I don't have the time currently to kind of take up all the things in data science. I don't know what it is. It's an unknown thing. I have to shift to something completely different. It can be any reason, right? So what do you do? How do you get onto the bandwagon of this machine learning and AI, right? Now, before we talk about how you go about it, but why is it necessary that you should start seriously considering about machine learning and AI as a career going forward, right? The reason is we just talked about the immense amount of growth in terms of the data that you see. Now, data scientists make sense of it, but then there is a lot of engineering to kind of take this forward. And in the coming days, there is a lot more emphasis and there is a lot more things which are going to happen in this space. And if you want to kind of um, take advantage of this situation, you should know this. It's essentially like 10 years back when I started off on AWS and cloud computing, there were very, very few people who understood cloud, right? But then 10 years down the line, I mean, I don't think any of us can think of uh, working on any applications beyond or outside of cloud, right? That's the same thing which I believe is going to happen with AI. It's not going to happen at all of a sudden. Suddenly things will not change. It will happen slowly, but as long as we are continuing to generate loads and loads of data, it's inevitable that we end up at a situation 5 years, maybe 10 years. I can't predict that, but it's going to happen, right? I mean, that is what we can see the trends of how the technology has evolved in the last few years, right? And that is the reason, and in my mind, that is the single biggest reason why you should seriously consider about machine learning. Now, when most of us, at least, when we are talking about a lot of companies and all, when we talk about machine learning or data science, in the mind, the perception that comes is, oh, okay, I'll hire a data scientist, and if I create an algorithm that is good, right? Now, which is exactly what happens. Now, that is the reason why you have over 80% of data science projects never making it to production, right? The reason is most of the times during the planning and the initial stages, it's only people think about the algorithms, but they don't think about various other aspects which are required to take this thing into production. Now, what exactly is the reality? The reality looks something like this. You only have the algorithms contribute to only about 15-20 odd percent of the overall effort or the time that you spend, right? A lot more time is spent in data collection, data validation, the feature extraction pieces of it, your process management, the tooling around it, monitoring and serving infrastructure and all, right? And similar to other software, you have configuration management and the resource management pieces. Now, I'm not saying this. This was basically published in a paper by the chief engineers who used to work on the various machine learning projects at Google, right? They published this paper in 2016, I believe, uh, which essentially within their own projects and outside of Google, they realized that 15 odd percent is what people spend in building algorithms, and there is a lot more work outside of these. And as we will see in the next few slides, most of these tasks are engineering heavy, and that is where I believe we as software engineers have a huge role to play. Let's look at a data science lifecycle. What are the various stages involved? Who are the various actors? And what is the domain dependency? Domain dependency is how much business knowledge do you need to actually be in that, right? Now, it all starts with defining the problem. Now, it might look simple, but defining the problem in the right manner is very, very essential, because it's very easy to say, I want to build a forecasting model, I want to build a price prediction model, I want to build something else, right? But why exactly are you building this model? What business metric is it going to impact? Is it going to help your customers like you more? Is it going to help your customers buy more? Is it going to kind of reduce your expenses? What exactly is uh, this model, or whatever your journey you are embarking upon to solve using machine learning solving, right? That's very essential. It's very essential to define that. The other thing which a lot of teams make a mistake is, it's also very essential to understand what are the various data sources you are going to employ in solving these problems. Many times teams start with the model in mind, the end goal in mind, everything in mind, and a couple of months later, after some 10 people have spent over 40 man days, they realize that they don't have the data to create the solution. So it's essential to understand the nature of the data, where the data is coming from, how what kind of data you have, at what cadence is like, is the data coming at a real time, is it coming every alternate day, what is the structure of the data itself, is it pretty structured, is it unstructured data, is it clean? All of these aspects have to be considered. Okay, now if you look at the various parts in this particular diagram, and I have color coded them, each of these, three of those which are in red, they are primarily engineering tasks, right? There is no other team that would be involved, especially if you are looking at data science or anybody else, right? They are not involved. Then you have four other stages out of these 8 stages where engineers play some role or the other, right? They may not be the sole guys to actually do this, but they play some role of the other, right? If you look at data, defining the data, monitoring aspects, deployment, testing, so they play different uh, roles to a different degree of importance in each of these stages, right? And there is only one stage which is pure data science, which is your modeling stage, right? That's the only stage where the data scientists work. But in today's world, especially when you are looking at some really complex problems where you are trying to solve these on cloud and etc., there also again the engineers come, either in the form of DevOps, MLOps, or any of the other roles, right? So essentially, if you look at it, there is only one stage where the pure data science guys come in. Everywhere else you need engineers. So don't kind of think there is no place for software engineers in data science. It's actually to the contrary, it is the opposite. You need engineers, right? I have an analogy here. If you look at something like Swiggy, sorry, that's a different this thing. If you look at a car, you need an engine to run the car. Now, the engine would require, it cannot run by itself, right? I mean, it would require a chassis, it would require tires, it would require a few other ancillary parts for the car to move. Now, depending on the money that you are willing to spend, you can probably get away with a Tata Nano or a entry-level hatchback to a high-end car like a Merc or a BMW, or ultra high-end sports cars of Ferrari and so folks like that, right? McLaren or Ferrari. Now, all of them require an engine, but the engine itself cannot do anything. If I give you an engine and you say, yeah, go ahead, you cannot, right? If you want to win the race, the engine is important, but the rest of the ancillary pieces are equally important. And in this whole machine learning AI engine, the way I see is, no, sorry, the machine learning AI car, ML modeling is the engine, and all your ancillary parts are the engineering side of it, right? All of them are required, all of them have to work in sync, only then will the car move. Otherwise, the car does not have a future. Okay, now let's move to a different slide where we try to see what are the various skills that we have here and what are the various roles, let's map people to responsibilities, right? These are the common terms that we keep hearing. Now, don't put a gun to my head, because as anything with data science, this is a lot fuzzy. This is one of the definitions that I can relate to the most, but then of course there will be somebody else who will contest me saying, no, this is not the case, right? So let's look at it. You have the data scientist who is an expert in engineering, data engineering, modeling, and the business, which is what we discussed a few slides back. And then you have the machine learning engineer or the software engineer, ML, depends. Some companies have, some companies have a different definition of the role, but the key skills here are the deployment part and managing the infrastructure, if you see. And if you look at it, if you are as a software engineer wants to make a transition and you have somebody in your data science, you need not be so good at the modeling aspect itself, but you need to understand very well the data engineering part of it, the deployment part, and the infrastructure part, right? And you have researchers. Not all companies have researchers. It's like companies like Google, Amazon, and all. These guys work on the problems which you will put in production 5 years later, right? I mean, what somebody did in Google some 6 years back is what we are probably using, right? So these people work on all the futuristic applications and trying to figure out, optimize, and do a lot of fundamental research in this particular field. And of course, software engineers, this is where we are. Software engineers, they know how to handle data, they know how to handle infrastructure, but then if you have to make the transition to do anything with machine learning, you'll have to go to one of the other roles that we see here. Depending on your aptitude, your interest, you can pick any one of those, right? So moving on, let's see, what does it all mean to software engineers? Give me 1 second. What does it all mean, right? I mean, we talked about what are the various things in data science, who are the various kinds of people over there. What does it all mean to you, which is the most critical thing that we are looking for. So try to understand the basic difference between traditional programming and machine learning. If you look at it, in traditional programming, you take data, which is all the inputs that you take to a function, let's say, and then you have rules. You have else, if, else, else, if, else, if, else, if kind of rules. And finally, you will have an else condition, right? Which, so when you give the data to this particular function, it will give you the answer. Now, machine learning works in a different way. In machine learning, you give the data, you feed in the answer, and you expect the machine to come up with the rule, right? And when the machine comes up with the rule, that's when you kind of you take the rule, and then you pass for this machine learning algorithm, you pass new data and you expect the answer. So you don't know the rules upfront. That is the most critical part. In software, whenever you build a software, more or less always you know the rules. If you don't know the rule, you kind of at least handle that in a catch-all condition, which is like either you kind of handle it as an exception or you handle it in your last else condition, right? But that's not what happens in machine learning. In machine learning, you give the machine the data, you give the machine the corresponding answer, and then you expect it to kind of learn the rules by itself. And when you feed in a production system the actual data, you expect that it gives the answer. Now, the challenge with this is another way of defining machine learning is its huge memory, right? So when you give a data point which it has not seen or stored in its memory, it will not be very, what it will try to do is it will try to come and guess with the closest answer possible. And more or less that is sufficient for us, right? But if it comes with it, if you give it a data point which it has never seen, or which is completely, I mean, out of bounds of its on what it was trained on, it will fail. But it will not tell you that I am failing. It will give you some garbage value, right? And in this case, garbage value may mean something extremely a wrong value. So think of it like this, right? I mean, you are you have trained a machine learning model to figure out whether an image is a cat or a dog, and now you give it a bird. Now it won't tell you that it is a bird because it has never seen a bird, but it has only seen a dog and a cat. What it will do is it will try to force fit it into one of these, which is it will say this is a cat, and then move on, which is like which is very wrong, right? And that's something that you have to understand when you look at programming for machine learnings, right? And when you're trying to create software products on top of machine learning, is machine learning systems, they don't fail just like that. You still have to put in guardrails which are outside of the system, which are again either rule based or in any other fashion, right? But you need to put in these guardrails. Now another way of looking at a ML product, right, is this. I call this the Holy Trinity. You have code, which is what we all are familiar with. The code changes with business needs, any bugs that happen, any configuration changes that happen, any upgrades you made, and all, right? And that is about the changes in most of the times. But then you also have, in a machine learning product, you have data, you have the models. The data changes because, think of it, you have the demographic data. You capture the sex, you capture the age, you capture the let's say the height and weight of the person, right, as a part of the demography. Now a few months down the line, you say I want to capture their location, I want to capture their country, or I want to capture their education level, which basically means it's still the same entity, is the same, which is the person, but then you have evolved the schema by adding a few more attributes, right? And similarly, if you look at the volume of data, you don't know. I mean, in a business like Just Eat and a typical food industry, the most of the volume of data flows during the lunch and dinner time, right? And once you cross 11 o'clock in the night for till about morning 7 o'clock or so, it's almost zero, right? Now, your system should be able to understand why the data is behaving in a particular way, right? And you need to be able to build systems like that. Okay. Now, models is essentially, this is pretty interesting, right? You have code, which is the algorithm in this case. You have data, you feed the data to the code and get something out, which is called a model. But the model itself has some parameters. Like there are typically, that algorithm has something called model. Every model, you provide something called model parameters, which you can tweak to kind of uh, slightly change the behavior of the model, right? And it will also help you in other things like how long it takes to train, and how fast it can respond to a particular query when it is to be in production and things like that, right? So though data plus code itself should be sufficient, there is a different entity here altogether, which is the model, and it has its own parameters which you can tune. Now, in any machine learning deployment, any one of these can change. If you look at the software deployments, only the code changes. But in something like this, any one of these can change, right? And that's what you as an engineer have to understand, work your head around, so that you can build systems on top, right? I'll quickly go through some of the challenges that you will see with data, which is unlike normal software. Um, One of them is data changes, which we discussed, and it's not like rules. You have rules, you have one or two more rules you keep putting in, and then you have a catch-all. But data is not like that. You can keep giving data, but then suddenly there is a batch of data which comes in, which is very different. So think of it. You may have built a application to give loans to college people, but suddenly the company decides we'll also give loans to people in their middle age, like 35, 40, or very senior careers, like about 55 odd. Now, each of these profiles are different. So if you had trained your algorithm earlier on a particular model, this changes, and that causes your models to fail. So you have to be aware of that. Data changes, and you need to know. History is important. I'll combine a couple of other points in the interest of time also. uh, and capturing data change is important. Why is this? So look at it this way: you place an order on Amazon or Flipkart or any of those things, right? Typically what you care about, and in most of our applications that we create, is what we care about is we care about the final status, which is basically we see that, okay, this order is delivered, or this order is in transit, and all of that, right? But from a machine learning perspective, or from a product that you are building on top of the data, it's very essential to know all the intermediate state changes, because that is what you are actually trying to optimize. So you are probably trying to optimize how long it will take for this parcel to reach the warehouse, or you are trying to kind of schedule that somebody should come and pick up this at the hub and deliver it to the person. You are trying to schedule all of these things. So you need to know, for you to be able to effectively plan and train your models for each of these intermediate states, you need to know these details, right? And you need to kind of change your approach to applications where you save each of these intermediate states, so that this can be piped back to your machine learning models for training. Then we have more, when you look at any data application, right? Or you basically will see that most of them are event driven, whereas in software the applications can be user or intent driven, right? You want to upload a file, you want to send a mail, you send a mail, right? But in data applications, a lot of these things are event driven. So whenever an event happened, so a user opened your app, that's an event. A user presses on a button, that's an event. So you are interested in capturing each of these details, and then you kind of build your applications, right? So most of the data driven applications which are using ML and AI, they actually use an event driven architecture. Now, the other thing which we also discussed shortly earlier is, yes. Hello, is it better? Hello, am I audible, Ramya?
Yes, you are audible, Ramya.
Okay,
Please continue.
Yeah. Sorry, maybe there was a break in between. So, and then the data is constantly growing now, which means that when you are serving 100 users versus you are serving 100,000 users versus a million versus 100 million users, right? The features may be exactly the same, but because your users are growing, how your models change, how you treat the data, how you clean the data, how you put in the various kinds of pipelines, etc., everything changes. How you store the data changes. So as your data grows, you for the same features to the end user, you have to kind of have a complete change in your underlying architecture in terms of how you handle, right? So when you have only 100 odd users, you can just write the basic thing. You can store it in even flat files or basic RDBMS, it works. But then when you are at 100 million users, these things will not work. You will start have to thinking about a complete big data pipeline for you, right? So that's something that you should be aware of. Data flows. What do I mean by that? As I was talking about, I think earlier, no, I was not. But typically, we are familiar with streaming data, which we associate with data that keeps coming at a regular interval, and we talk about batch data, which is probably comes once a day or twice a day or once a week and things like that. But the way you should think about this is in terms of what do you call about data which comes every day at a particular time? Is it batch, or is it some kind of a reduced streaming kind of a thing, right? So the way to think about it is there is a different concept that has been put forward by Google some time back, which is called the data flow programming paradigm, which you talk about unbounded and bounded data sets. So that's a concept that you should get in. Now, a lot of this happened on AI ML is only possible because of all the things that happened in the big data world and the cloud world. So if you are playing a part, want to play a part in the machine learning world, it's essential that you kind of know and be able to take care of parties. I mean, you kind of have some grasp on the cloud and the big data world, right? Where do we go from here, right? See, what you need to learn is nothing new. It's a old wine in a new bottle, right? I would go with 4 concepts here, which you would need. But before that, just to help you with a fact, most of the math that we currently use for data science or machine learning and all, it was invented long back. Okay, the first neural networks uh, that came out even before the computers came out, right, in 1940s. And this is even before you had databases. I mean, relational databases, if I remember, came in 1960, mid 1960s, right? So neural networks are that old, and a lot of these concepts that we use from gradient descent and all, these are all again very old concepts, right? So focus on the concepts. The concepts that I would request you guys to focus on is the system, the software engineering and the system design aspects, which anyway most of you focus on. Then SQL, this might be a bit surprising to you, but I would say that knowing SQL is one of the key things that you can do if you want to participate in this area. The other thing, which is very few, not very often they talk about it, visualization, right? You may think, why is this important? In my mind and in my experience, I have seen that a lot of times just doing the right visualization can help you understand your data and your business better than any model can ever do. Okay, and a mentor of mine, he mentions this, that visualization and ML modeling are different sides of the same coin, right? Essentially, your core idea is to figure out what are the key levers or the key attributes that you have. And then, of course, distributed computing, I would have put cloud. But what is also important is you should know how to use GPUs. You should know how to use things in a connected world, like you have compute on the edge. These days, you have ML on edge. So you think of, which is Google does, right? If you have used Android device, you know there is this keyboard which has the Swift key. Now that has machine learning, and that machine learning runs on your mobile and communicates the results back to Google server, and Google consolidates all of these things, which the models which are running on a billion different devices, they combine, right? So understand the concepts behind distributed computing. uh, this essentially, I was going in detail on each of these. One thing you remember when you're working in your companies, and I think this is the only advice that I have and request I have, is when it doesn't matter which group you are in your company, which module you handle and all of it, right? Because just like you see, you only work on your module, but be curious, try to ask others, try to talk to your colleagues, and try to get a overall picture, right? I mean, and if you want to learn system design, there are lots of content available on YouTube and all, but understand your system as a whole, not just one particular piece, right? Spend time on that. I already talked about SQL. If you want to learn more about visualization, visualization is not coming up with a pretty looking graphs, right? Visualization is about communicating the and in a easily consumable format, the complexity of the data that you have. That is the way I define visualization. Grammar of graphics is a very common terminology, and I would suggest deeply that you guys spend a little bit of time in understanding how to visualize data properly, right? And we already spoke about distributed computing, which includes IoTs, cloud, GPUs, edge computing. Pick anyone. Cloud is the one that you can start off, because I believe most of us are on cloud applications these days. So look at that. Then we also have, that's mostly about it. I would leave all of us with one thought, which is a quote from Albert Einstein, right? I have no special talents. I'm only passionately curious. And I believe this is true for machine learning. You just have to be curious, right? Ask as many questions. How does this work? How does this work? How does this work? Why is this the way it is? Keep asking questions, and that is the way that you can uncover the knowledge for yourself. Now, I have a few resources here. This is not an exhaustive list of resources. This is something that I like it. I personally prefer to kind of go a top-down approach, where I say that, okay, I want to have an app which takes my photo and modifies it to a sketch or whatever, right? And then try to learn how it does it. So there are a few projects that I listed here. I'm sure the folks at Verwin, they will share the presentation probably, so you can have access to this. But there are many others. Like you search on GitHub, like you will have thousands and thousands of projects. So don't stick to these three. These are three which I know and I felt they can be useful as a starting guide for people who want to start off. And that's about it. Sorry, I consumed a lot more time, probably about 10 minutes extra. Uh, I thank Verwin, Satya, and Sunil for this opportunity. Open to questions.
Yeah, Ramjee. This is Srini. We have a few questions. I responded a few questions, just simple, but we have a couple of more questions which I thought which I reserved for you.
Sure.
So one of the questions is, can you explain research oriented in AI? I don't know what that means, but that's a question.
Research oriented in AI.
Yes.
Okay, I'll try to attempt. I mean, from what I understand of the question, probably, right? What I believe this person is referring to is like AI research. Now, as I mentioned earlier on in my slide, there are a lot of problems which are not solved. And if you look at things like image processing, things like natural language processing, they are very, very hard problems. Even if you want to kind of identify, let's say, classify, right? I'll give you an image and you have to tell whether this is a dog, cat. All these problems are solved, but then you have to you have a lot more complex problems which we as humans can distinguish very easily, right? But the machines cannot. And one of the things recently we have heard about IBM machines, IBM stopping their facial recognition thing, and that's a big problem. Like you have to give unbiased data, but then can there be other algorithms which will also, even if you give biased data, they can figure it out? That is one kind of research thing, and there are many other problems. I believe that is what it is. And a lot of these companies and at universities and all, people are solving and trying to work on those.
Okay, I am a beginner. Please tell me how to start and where we start learning machine learning.
Good question. Just like as I showed, I don't suggest that you start with a course which talks with deep in machine learning and all of that, because what happens is by the third session or so, where you learn a lot of math and all, you are bored enough, and then you will probably never come back. My approach would be look at courses and look at projects where you can pick up a already working application and then try to dig back, try to understand how they code it, try to change the code, what happens, tinker around with it, right? Fast.ai is a deep learning course. I mean, though I know you asked about machine learning, I would suggest people to kind of pick up fast.ai. It has a very good approach, which I like. They take a very practical approach. You are trying to solve practical problems, not spend 6 months, 1 year in trying to learn the math. I'm not saying math is not useful. What I'm trying to say is don't get buried in deep math and forget that your intent is to become a machine learning engineer and not necessarily a statistician, right? So start from a problem statement in mind. Pick up some algorithm. Hundreds of these things would be available online on GitHub itself. So pick that up, try to run it. You will have to learn a little bit on how to run it, but most likely you can run it without knowing anything else. Just your software knowledge is enough, right? You take that forward, then try to tweak around the things, and then compare with any of the courses. It doesn't matter which course you take. I mean, most of the courses are good out there. So then take a course, combine these two and proceed, right? I would say take a practical approach to your learning and not a theoretical approach.
Next question. This is a very interesting question actually. If I'm able to detect glaucoma in eye and I wanted to show it through a augmented reality application, is it possible? I don't know the answer, so I thought I'll check with you whether you know the answer.
You can detect glaucoma in eye, yes. You want to show it in augmented reality. So
reality
essentially what you are saying is a doctor will wear a HoloLens kind of a device and look at you in the eye, and then it will say glaucoma is there. I think it's possible. Fantastic idea. I mean, you should take this forward. But saying that, just detecting glaucoma in the eye using the image itself, I guess, is a breakthrough, right? I mean, though I know I have heard people attempting to it, I don't know if this is at mainstream, because there would probably be a lot of clinical trials and all required. But idea looks fantastic. I think it's doable. But saying that, even part of the idea itself, which is detecting glaucoma using machine learning, that itself can be a breakthrough.
Okay, so next question is, what is the difference between classical AI and statistical AI?
I am sorry, I don't know the exact difference between these.
Okay, that's fine.
I'll check up.
What is AI? What is AI neural network?
Okay, it is what we talked about, right? I mean, artificial neural networks. So if you look at machine learning, I mean, most of the machine learning is built on the stats, right? And then when you look at neural networks, they are trying to kind of simulate how your brain works. So your brain is a huge collection of neurons, right? And it has these neurons everywhere in your body, where whenever there is a stimulus or something, the neuron gets activated, a particular neuron gets activated, and it sends the signal to a particular part of the brain, right? Now, the neural networks design is also done in a very similar fashion, and that is what it is. It's basically artificial neural networks. And typically in the earlier generation, artificial neural networks used to be one layer of neural networks or neurons. You give inputs and then you have a layer of neurons, and it will give you the output. In deep neural networks, now you have multiple layers. You will have like n number of layers. There are some networks which have thousands of layers in between, right? And that's the reason why these deep neural networks are much more complex. At the same time, they can do a lot of things which are very hard to do otherwise.
Another question, what is the difference between supervised machine learning and unsupervised machine learning? We just want to know.
It's basically like supervised machine learning. I can kind of say, like, you are in a class and a teacher tells you this is this. They are teaching you, and you are learning from them, right? Unsupervised is you are left in a playground, you are with your friends, and you have a ball. You probably watched somebody playing football, and you are trying to mimic it and learn by yourself. So the same thing applies here. Supervised machine learning, to the machine learning model, you give the data. You saw the earlier slide where, and you give the answer, which is like, you say that if this is the data, this is the answer. That is supervised, right? Then in unsupervised, you basically give the data and you say, like, I don't know what this data contains. Can you help me figure out? So it will then try to, you will use different algorithms to figure out, the clusters. Like, okay, we'll say that, okay, out of the 100 data points that you gave, 10 belong to of the same kind, 20 are of the same kind, and stuff like that. So in many practical problems, you go from unsupervised to supervised, and then further, right?
Okay.
Hey guys, welcome all of you to the virtual Coda Developer Bootcamp. I am Sneha Damble and I am part of
Hello.
Yes,
Srini.
Mr. Ramjee,
Yes.
please continue. Yeah.
Hello, Ramjee.
Yeah, Srini.
Yeah, can you give me, can you explain what is NLP?
NLP is natural language programming. So let's say whatever text you asked, right? Now, how does a computer understand what exactly you asked? You said, if I read the question, can you explain in detail about NLP, right? Now, it's a question that you are asking, and my brain processes it like that, right? And most of us who understand English will process it like that. You are asking a question, you are asking a question about NLP, and you are asking me to detail about that, right? Now, It's the same thing. So the NLP part of AI deals with this aspect. It basically goes through the sentences, goes through
Hello, Ramji, I think you got muted possibly.
it is forcing me to mute, automatically muting me. Sorry for that. I'll just hover over here. I don't know when I got muted, but I was saying NLP is basically the part of AI that deals with uh, processing text, making sense out of it, and then yeah, that's what basically it is for. So the practical applications include your chatbots. When you ask a question on a chatbot, it responds. So that involves a lot of NLP there.
Okay. Someone is asking, what will happen 2-3 years down the lane? Now everyone seems to be shifting 2-3 years down the lane. There will be any scope for machine learning AI? That's a question.
So I don't see that it will be a saturation. I don't think it will get saturated. What will happen is we see that there is a lot of data that is going to be generated. So you will need people who will work on this particular thing. But I definitely see that a lot of hype that we currently see may be reduced. It will be more like, if you look at it, there was a lot of hype around cloud some 4 or 5 years back, or digital transformations a few years back. But then now it becomes the norm. I mean, that's the way of life, right? I think that is the way it would become. Or the same thing with software. I mean, think of, I don't know how many of us are old enough to remember those days, but the late 90s, the Y2K and all of it, software was a huge hype, right? But then now software is like essential. I believe AI ML would go the same way. The hype will die down, of course, but you will see that there are a lot more requirement for people in this space.
Okay.
That's my
what
view.
What are the trending programming languages and tools for the AI ML?
Don't go by trends. Go by the concepts. If I am on this, if I am on Python, I would continue with Python. If I don't know Python, I would learn Python. That's something that can help. Not because it is just the trending language. The reason is most of the work, a lot of libraries and all are available for Python. So that's the reason I would look at Python as the language that you should look at. From frameworks perspective, they're pretty standard now. You can pick up scikit-learn, which has been there for like almost, I guess, 20 odd years now. That is very popular. Use scikit-learn. If you are looking at data, deep learning, use PyTorch. I think these three are good to start if you are looking at that.
Okay.
Python would be the language. Yeah.
Okay. Can you give an example for in urbanization without harming nature? Can you give a AI ML example? A
I'm
startup
sorry.
idea. Can you provide it?
I'm sorry. I mean, see, the way I would look at is, okay, I'm not an expert on figuring out the problems, but the way I see is, if I have a problem, then you can apply AIML to it. Where you can apply AIML is, you have lots of data, or you have data, but it is very hard to find the correlations between the data. That is where you should be looking at machine learning. To give you one example is, think about it this way, right? I was discussing with a friend of mine just yesterday, so this helps. Uber releases its urban car data on a quarterly basis. So it will give you all the details around how long did it take from one place to another place, of course, anonymized. Now you can use that data, club it with the maps data that is available, club it with let's say the sanitation data, and maybe you can come up with how and when these sanitation vans should come, or you can probably club it with data that is available from companies like Blackbuck or so, which are into transportation, right? I mean, trucks and all. so that the trucks don't come into cities. You can optimize that. That can be one. I don't know. I mean, there can be a lot of problems, or you can probably say which areas have less parks, or can we do something around that? There can be various things. You have the data available. It's possible.
Okay. What is TensorFlow?
TensorFlow is one of the deep learning libraries. This is from Google. If you want to do deep learning, especially on images or on text, TensorFlow is one of the libraries. It's deemed to be a little harder to learn. I would recommend PyTorch if you are starting off, but if you want to pick up TensorFlow, yeah, you can pick that up.
Do I need to have some other coding background before starting to code for AIML?
No, nothing. You just need to be curious. You just need to be interested. You actually, this thing is more than coding. You need to know SQL. You need to know the concepts to understand data, right? You need to be able to kind of look within the data, process data, like either through SQL or, I mean, basic SQL will take you a lot more forward than knowing Python, because just knowing Python or Java or any other programming language will go take you only to X level, but knowing SQL, ability to manipulate data, that will take you a lot much farther.
Yeah, and the last question: how will AI impact application development of today?
Interesting, very interesting, right? I mean, just today I was watching a video on. If you have heard of there is this I would entity, I would say a commercial entity called OpenAI. You can look it up. So they actually released a video where you just write the function name, and the AI will complete the rest of the function. So it will basically code for you, right? I mean, I mean, though it was a demo, I was pretty impressed by the kind of code generation it did. If it's possible, something like that, it's basically means all of us are in for a very, very different times, right? I mean, some of it is interesting, some of it is tough times. So it can have a lot of impact. You are already seeing there are some companies which, if you tell them these are the blocks that I need, you just feed them the content that you want, and they will generate the site for you. They will generate all the elements based on for your business what is the most optimal thing. So it's already in there, just that they are not very widely adopted. They have their own challenges. But a very good question, right? I mean, I can't predict the future, but I already see signs where people are attempting things like this, and with some degree of success. I'm frankly, I'm like not very sure where the world would go, because it's a bit scary, but at the same time it's exciting.
That's all questions I have, Ramji. Thank you for answering all the questions.
Thanks, Srini. Thanks for taking up to answer the questions. Sorry, ask the questions. Sorry.
Thank you so much, Mr. Ganti, for that insightful session. I'm sure our participants have a lot of takeaways, like the concepts to focus on, how to upskill and participate in AI as software engineers. Really grateful for having you on this webinar today. And I would also like to thank our friend, Mr. Srinivasan, for superbly moderating the Q&A session, especially answering a lot of questions while in the chat itself. Thank you so much. And I'll also like to thank everyone here who joined us and participated in this webinar. I hope all of you had a good time. Please stay tuned for more such webinars in the future. Also write to us on alerts@verwin.com if you would like us to host such knowledge sessions, and please register on www.verwin.com to get expert answers to all your career related questions. Thank you so much, everyone. We'll close this session now. Thank you.